Hello, everybody. My name is Andrew Keegan. I am at Andy Keegan over on Twitter. I'm a primary school teacher with a specialism in music, and I'm also my school's mathematics and numeracy coordinator. Um, I'm very pleased that the nice people over at Bread Cymru have afforded me the opportunity to combine those two things and to talk to you today about maths in music. Now, it is a slightly misleading title, and I'll explain that in a little while, but the general gist is I'm going to be talking about maths and numeracy in some aspects of music. Now, to begin with, what I'd actually like to do is just put a little bit of this into context, and it all comes down to the LNF, the Literacy and Numeracy Framework. I moved to Wales in 2011, and I was ahead of music in a comp from 2012 to 2014, which is around about the time when the LNF was starting to gain a bit of traction. After the OECD, I believe it was, had done their assessments and whatever it is they do, they decided that Wales was not performing as strongly as lots of other countries, not every, but some other countries. So the Welsh government decided to do something about it, and they devised and released the LNF. The issue this had was it was kind of thrown out, and lots of people started panicking. Because they were under the impression that they had to teach all of these maths and numeracy and language skills in their subject, irrespective of what their subject was. However, it wasn't as overarching as that. It was actually relatively straightforward. It was just if you could incorporate some of the skills and focus on literacy and numeracy in your subject, then you should. So I spent quite a long time, a few years actually, looking for the opportunities for literacy and numeracy in music, which is where some of this comes from today. So some of what I'm going to talk about today is, well, it's all musical, but in some contexts I'll teach it as a music lesson. In some contexts I'll actually teach it as part of a math lesson rather than music. And I'll show you how that works in a little while. So I could talk about this for hours and hours and hours, but obviously I haven't got hours and hours and hours to talk about it. So what I've done for this particular session is I've focused on specifically number and then patterns and sequences. Again, if there's any musicians watching and listening today, some of this information won't be new to you, but I hope for everybody there's at least one thing that you can take away from today. Even if you use one small aspect of this in a lesson or give an idea a go, then I'll be really pleased. So let's start off looking at number. So the obvious place with that symbol on the screen, the obvious place for me to start is looking at notes and note values. So this is a semibreve, we've got a minim here, we've got a crotchet, a quaver, and a semiquaver. Now, you could keep going. You could get demi-semiquavers and hemi-demi-semiquavers and semi-hemi-demi-semiquavers and keep on going, but they just get absolutely ridiculous. But the numerical idea behind them is all pretty straightforward. So a semibreve is worth 4 beats. There is actually a note called a breve, which is worth 8 beats, but it seems to have gone out of fashion. You mostly find breves in kind of older choral music, and as a composer myself, I've only ever used breves, I think, in one composition ever. They're not very common, so although it's called a semibreve, it's actually much more common than a breve. So that's 4 beats. A minim is 2 beats, a crotchet is 1 beat, a quaver is half a beat. I'm sure you can see where this is going. A semiquaver is a quarter beat, and if you kept on going, you'd have an eighth and a 16th and so on and so on. Now, in terms of the half and the quarter, these are in relation to the crotchet here. So it's not half of a semibreve. Here, it's half of a crotchet. So it can get a little bit confusing, but I'll explain another way of looking at it in a second. Now, I really like using these numerical values as quick starting activities. What I might do is I might print out the notes onto little playing card size things and dish them all out to the class. And then, a bit like a PE starter, I might ask them to get themselves into groups that add up to 8 or 12 or 15 or 4 or 3. And that's always one that confuses some of them, because some poor pupil is always going to end up with a semibreve and can't get themselves into a group of 3. But what it does is it gets them thinking really, really quickly about addition using halves and quarters. I'm thinking very, very quickly as well. So that's a nice quick activity. And also, sometimes what I'll do is I'll use the note values to create mathematical questions. So I might do a semibreve plus a semibreve on a really simple level, or I might, as the pupils get older, make them more complicated. You see a lot of problem solving with symbols and ideas like that. So there's plenty of scope for using musical symbols instead. I do a really fun activity where the pupils have to open up a padlock which has got numbers on it. And basically what they have to do is I will create notes which are all tied together or joined together, or they'd be part of a question, and they've got to work out what the values are to work out what the numbers are on the keypad to open the lock. So it's just another way of kind of thinking a little bit more outside the box instead of just using numbers and fractions of halves and quarters. Now, if you talking of fractions, if you were to lay these notes out together, a semibreve would last for 4 beats. You can see the beats I've put at the top of there. So the semibreve would last for those whole 4 beats. So to make the same amount of time, you would need 2 minims, you would need 4 crotchets, 8 quavers, and I'm sure you can see where this is going. You would need 16 semiquavers. Now, the eagle-eyed of you out there will probably see straight away that actually what you've got in front of you, even though it's laid out slightly differently, what you've got in front of you there is a fraction wall. Now, if you were to swap out those values for a whole number and then break it down, you can see how many of each one you need to make up the one above it, or how many you need to make up the one below it. Now, this is where I mentioned before that it can get a little bit confusing, because a semibreve at the top is worth 4 beats. Musically, if you're playing one, it's worth 4 beats. However, when we look at fraction walls, we refer to that one as being the whole. But if you look at them like this, if we take away those names, if we think about the American terminology, now American terminology is actually a little bit more relevant in this case, because that note at the top there is actually called a whole note. And I'm making a little bit of an assumption here, but I imagine a lot of it comes from the fact that most modern popular music is written in 4 beat per bar time signatures. So a semibreve would fill a whole bar, which is why it's called a whole note. A breve, on the other hand, would be called a double whole note. So a whole note, although it's worth 4 beats in American terminology, it's called a whole note because it fills a whole bar. So that means that the minim is a half note, and then you've got a quarter note, an eighth note, and a 16th note. Now, that can get a little bit confusing, because, well, why is a whole note worth 4 beats and why is an eighth note only half a beat? So you do need to be a little bit careful when using them. But in terms of building a fraction wall, that actually makes a lot of sense. And a really fun activity, I picked this up off of an American blogger's website, was to use let's see if I can highlight it here. This brick here, this Lego brick here, has got 8 little notches on the top, and that becomes your whole note. And then what you do is you then assign the relevant Lego bricks and draw on them what it is that adds up to the same thing. So if you have a look at the top here, I've got a crotchet and a crotchet, which is worth 2. Now, I've got another note here, which is actually a dotted crotchet. And again, this is where you need to be thinking really carefully about your knowledge of fractions, because what this dot actually does is it adds an additional half of the value of the note that it's attached to. So here we've got a crotchet with a dot, so it adds an extra half of a crotchet, which is a half beat. So this actually now becomes 1.5 beats long, so you need this extra quaver here. And the same with this one. This is a minim, which is worth 2 beats, but because it's got a dot on it, it adds an extra half of that 2 on, so this actually becomes a 3 beat note. So just that understanding and that depth of understanding from fractions is pulled out all the time in music. And then you might see symbols that look a little bit like this. This is just 2 quavers with a beam on them here as well, so it looks slightly different to this, but it still adds up to, you can see it adds up to a crotchet. And what I also like to do with this Lego stuff is, you can see here that we build rhythms, and you can actually change the rhythms as much as you like. So you could get pupils to build this rhythm here, and then they could have a go at playing that rhythm. Now, if you wanted to simplify it slightly, if you didn't want to have dotted notes, you could just take them out and just have simple rhythms instead. But the more confident you get and the more confident your pupils get, they can easily add in these and make much more complex things. What I also like to do with that is I do like to put the fraction wall on the other side. So if you flip the pieces round, what you end up with is you can see the fractions and how they all fit together and how you've added them all together in different sequences. But then if you turn it back over, you can see the musical notes that apply to them. Now this counting bars, this is an activity that I've done for years and years and years. When I started out learning how to read and write music, it was actually something that we did in theory lessons. So we would start out with our time signature. Now our time signature sort of works in the same way as a fraction itself. Just like a fraction has got a numerator and a denominator, the top number and the bottom number mean different things. So the bottom number in this case, this 4 here, actually tells me that I need crotchet beats per bar. Okay, so this one is crotchets, and this is I need 4 crotchet beats. So if I showed you something like this, for example, or just a whole selection of notes, one of the activities we would have to do is to draw boxes or circles or whatever around each group that added up to 4. So starting at the beginning, so starting here, we would draw a circle or a box around them and then keep on going until we ran out of notes. So the first note, if I can find it here, the first note would be this section here. So you've got a 2, a 1, and a 1. That adds up to 4. The next one is just this note on its own, which adds up to 4. These next ones add up to 4, and these next ones add up to 4 here. So straight away, a very, very kind of early stage of learning music, we're thinking of adding in very different situations, different ways. Now, if you turn that into something which is a little bit more musical, you would add in bar lines instead. That's exactly the same principle. We're just adding a bar line at the end of every group of 4. So you can see those boxes are sort of starting to appear like that. And you can make them as complicated or as simple as you like. So for example, something like this, although it looks very complicated, if you work your way through it, you will actually see that that amount of notes there all actually add up to 4, because we have a half and 2 quarters. So that those notes there make up 1. We've got another quarter, a half, and a quarter, which make up another beat. Now these, as I mentioned before, these are the same values as these ones. They're just joined together. So these 3 here, 1, 2, 3, are actually exactly the same as these. It's just these ones are beamed together, whereas these ones here are actually written incorrectly. If you're going to write quavers and semiquavers together, you should actually beam them in various groups like this. But this is just to kind of show you how they would fit together. So actually all of those together only add up to 4. And again, you need to have quite a deep understanding of halves and quarters and adding them all together to be able to understand how that would work. So moving on from numbers and counting, now there's plenty of other things that we could do in terms of numbers and counting. Lots and lots of opportunities for number work and fraction work in music, both in maths lessons and music lessons as well. Unfortunately, I haven't got an infinite amount of time to talk about it, so I do need to move on to I'm going to look at patterns and sequences. Now, music is actually filled with patterns and sequences. You just need to know where to look and what you're looking for. Now, when we're teaching patterns and sequences, and I've done this with my children. My children are 5 and 8 at the minute, so I've had tasks, especially during lockdown, where we might get sent something like this. You've got a square, a circle, and a triangle, and then what you need to do is continue the sequence, continue the pattern. So obviously we would go square, circle, triangle, square, circle, triangle. And these would get more complicated. They might change the colors of the shapes and what have you. But the principle is exactly the same. You're just following a pattern and repeating a pattern over and over again. And the same applies to numbers. One of the skills we teach is counting in various different amounts from different starting points. So here I've got 1, 3, 5. And so the question is, what are the next 2 numbers in the sequence? So 1, 3, 5, 7, 9. But you might start counting in 2s on a different number. You might start on 21 or 27. Or you might count in 10s starting on 36. But the idea is the pattern is exactly the same. You're just starting from a different place. This is a very well-known pattern here, 1, 1, 2, 3, 5. So the question is, what are the next few numbers? And that, for those of you who recognize this, it's the Fibonacci sequence. I could spend an hour just talking about music in the Fibonacci sequence, which I'm not going to do. But what I do suggest you do is if you get over to YouTube and just search for examples of where people have used Fibonacci sequences in their music, it's mind-blowing how interesting the music actually ends up sounding, particularly rhythm-wise. There's lots of Indian musicians use Fibonacci sequences to create incredibly complex rhythmical pieces of music. Okay, so thinking in a more musical way in terms of patterns and sequences. If I showed you this particular pattern, so 1, 5, 8, 5, 8, 5, and then I gave you the number 1 again, my question would be, what are the next numbers in the pattern? So you would say 5, 8, 5, 8, 5, and you keep on saying that's my pattern, that's my sequence, that's how it goes. 1, 5, 8, 5, 8, 5. But what if we were to assign those numbers to a musical note, for example, or a scale? So in this particular example, I'm going to use the A minor scale, okay? Okay, if I played it as a natural scale, I wouldn't have put the G sharp in the top. I just play a G like that. Okay, now if I play the first note of that scale, I get an A. If I play the 5th note, I get an E. And if I play the 8th at the top, it's another A. So I've got 1, 5, 8. And those are the notes that I'm going to use. So if I assign those to notes, they would look something like that. So I've got 1, 5, 8, 5, 8, 5. And it would sound like this if I played that. And if I played it over and over and over again, you can actually hear the beginnings of a piece of music. And it's really, really simple. If I then continue with the 1, 5, 8, 5, 8, 5 idea, but I change the starting point, much like we do with patterns and sequences with children in school. We might say count in 5s starting at the number 7, or count in 5 starting at the number 2, or count in 5s starting at the number 28. So in this case, instead of starting on an A and getting those notes, I'm going to start on an F instead. So still following the pattern of 1, 5, 8, 5, 8, 5, I would get this. And then if I change it to another note, I would get this. And you get a really, really nice sounding, even more complete piece of music. And any musicians out there, particularly pianists out there, will probably recognize this is one of the most probably recognizable and famous pieces of piano music you'll probably have heard. And if you put it together as a piece with the other aspects of it as well, it sounds like this. Because what it actually is the left-hand, the bass part from Michael Nyman's The Heart Asks Pleasure First. And there are lots and lots of examples like that, and you can use this idea when you're doing some composition with your classes, if you're trying to write some music, as you can assign numbers and patterns to various notes and things like that, and you end up with, and if you just repeat them, you start to end up with some really quite interesting and worthwhile compositions. I'm going to finish off just by talking about these letters here. Because again, talking about patterns and sequences, there are the letters C, F, G, and F. Now again, not everything in math lessons, when we talk about maths, actually what we're talking about is maths and numeracy. And using these skills beyond number is really, really important. So if I gave you the letter C, for example, and said, what are the next letters in this sequence, you would say F, G, F. So this goes C, F, G, F. So we go C, F, G, F. Now, again, if we apply a little bit of musicality to this, actually what those letters mean they are chord symbols. So here is C, here is F, here is G, here is F. And if you repeat them, again, you can start building something a little bit more musical. Now, if I move on to this particular pattern, this is probably one of the most famous and well-known chord progressions in the world. And it goes like this. You've got C, G, A minor, F. And again, if I were to say to my class, what are the next chords in this sequence? They would say C, G, A minor, F. And those chords, if you were to apply the number system to them, that would be chord 1, 5, 6, 4. And you hear that chord progression in many, many, many different types of music. There's a brilliant video by The Axis of Awesome. If you haven't heard it and you want to play it, what I suggest is if you search for the 4-chord song, where they basically play those 4 chords over and over and over again, and they sing countless different snippets of songs over the top of it. However, a word of caution is there are different versions. There are clean versions and there are some slightly less appropriate versions. So you might want to just double check. But again, it's just another example of where musical sequences are actually used to create something which is very worthwhile. So unfortunately, I've run out of time today. Like I said, I could spend hours and hours and hours talking about where math and numeracy are found in music. I've got some lovely activities on kind of symmetry and patterns using using a bit of software called Chrome Music Lab, and you can find out more about that if you head over to my blog, which is musicularium.wordpress.com. However, that is all the time that I've got today, so I'm going to say thank you very much for listening in, and a massive thank you once again to the Brewed Cymru team for making this possible. It's been a long old time during this particular pandemic. I say this pandemic, where people haven't been able to share ideas and haven't been able to as easily access additional CPD, which they would have been doing over the past few years if this had not been going on. So a massive thank you to the Brewed Cymru team. If you want to chat any more about anything that I've spoken about, or if you want to share, if you use some of these ideas and share them in your lessons, then please message me over on Twitter. But apart from that, thank you very much and enjoy the rest of the day. Thank you.